Today we're going to discuss about book The Age of AI about authors. Henry A. Kissinger served as the 56th Secretary of State from September 1973 until January 1977. He also served as the Assistant to the President for National Security Affairs from January 1969 until November 1975. He received the Nobel Peace Prize in 1973, the Presidential Medal of Freedom in 1977. Our second author is Eric Schmidt, is an accomplished technologist, entrepreneur, and philanthropist. As Google's chief executive officer, he pioneered Google's transformation from a Silicon Valley startup to a global leader in technology. He served as Google's chief executive officer and chairman from 2001 to 2011, executive chairman from 2011 to 2018, and most recently as technical advisor from 2018 to 2020. Under his leadership, Google dramatically scaled its infrastructure. Our third co-author is Daniel Huttenlocher, is the inaugural dean of the MIT Schwarzman College of Computing. Previously, he served as founding dean and vice provost of Cornell Tech, the digital technology-oriented graduate school created by Cornell University in New York City. He has a mix of academic and industry experience as a computer science faculty member at Cornell and MIT, researcher and manager at the Xerox Palo Alto Research Center, PARC, and CTO of a fintech startup. He currently serves as chair of the John D. and Catherine T. MacArthur Foundation Board and as a member of the Corning Inc. and Amazon.com boards. Book, The Age of AI. From Turing to today, AI has progressed rapidly from theoretical concepts to advanced technologies like machine learning that continue shattering our expectations. It was 20th century scientist and philosopher Alan Turing who proposed a pioneering evaluation to ascertain whether machines could exhibit human-level intelligence. His idea was to give machines creative challenges rather than mathematical tests. Turing described an experiment in which a human evaluator would hold written conversations with a computer and another human, without knowing which was which. The evaluator would then judge the machine's ability to demonstrate human-like responses, reasoning, and emotional intelligence through its natural language capabilities. This approach placed emphasis on testing a machine's capacity for tasks like language fluidity, problem-solving, and adapting to new information. Mathematical prowess alone wasn't enough. Turing's criteria for intelligence, known as the Turing test, remains influential today, shaping key benchmarks of AI progress beyond speed and accuracy metrics. Researchers found rule-based code alone couldn't replicate human cognition, so techniques using neural networks, that is, networks of nodes used for machine learning, were developed in order to enable AI to learn ambiguous, imperfect information just as we do. If you feed an AI enough examples of molecular structures and antibiotic effectiveness, it will predict potent new medicines unforeseen by science. Feed it classic novels and news articles, and it will spit out original, often eerie stories. In addition to commanding programs to do exactly as they are told, code has been developed to learn based on training data. Examples of molecular structures and antibiotic effectiveness, it will predict potent new medicines unforeseen by science. Feed it classic novels and news articles, and it will spit out original, often eerie stories. In addition to commanding programs to do exactly as they are told, code has been developed to learn based on training data. In the field of biology, the protein folding prediction system AlphaFold demonstrates this well. It achieved accuracy ratings far above existing science by training on DNA data, allowing biologists to validate theories at unbelievable scale. To do this, scientists utilized huge databases such as the Protein Data Bank, which contains over 170,000 experimentally determined 3D protein structures. They also used datasets like UniProt, which include millions of protein sequences without known 3D structures. With the combined information from these training sets, AlphaFold learned what properly folded proteins should look like and generalized what proteins hadn't already been solved. After a lot of refining, this training produced unprecedented results to predict protein folding and opened possibilities to better understand disease and drug interaction. As many advantages as there are, AI has its limitations, and these are often revealed through bias and unpredictable mistakes. Flaws in training data or human oversight can severely skew system outputs, like how Microsoft's chatbot Tay began spewing racist, sexist language after public interaction, and lack of context when processing information causes AI bloopers no person would make. Large language models, such as ChatGPT, work by training the AI system on massive text datasets, allowing it to learn nuanced patterns about how language and writing work. The systems predict the most likely next word in a sentence and build fluent, human-like text. Large models optimize to continue text sequences fluently, not for accuracy or truth. So without oversight, they can confidently generate believable, yet completely invented or unethical text, like what we saw in Tay. It's therefore crucial that we instill accountability so AI reliably aligns with ethics and social benefit. Countries implement professional certification, standards, and compliance monitoring because the technology's growth will not slow on its own. But exciting possibilities lie ahead if guided properly, with potentially AI lawyers, assistants, even artists, producing astonishing creative works reflecting the diverse beauty of human cultures. If you like the video, don't forget to like, share, and subscribe for more video like this. Thank you.